Hey y'all. So this is 3637 doing a video today. My son is napping, so if he wakes up, he will come into the room. So I apologize if we are interrupted. Hopefully it's cute and not him angry because toddlers can go either way. Yeah, but here we go. So let's see what happens. So derivatives of exponentials and log functions. Overall, I think they're not too bad. They're pretty easy. So the derivative of an exponential in general, so d over dx, so the derivative of an exponential, b to the x is the natural log of b times b to the x. So it's like a copy paste times the natural log of the base. Copy paste times the natural log of the base. E is the best derivative ever. It is its own derivative. Okay. But let's not forget about chain rule down here. Let's not forget about chain rule. So if I have, well, with the E. So if I have e to the g of x, right? Then it's copy paste job, then times the derivative of the exponent. Same thing if it's a different base. Like let's say the base is, I don't know, 2. So if it's 2 to some function, oops, sorry, this is the dx, the derivative. So if y is 2 to the g, then y prime is copy paste 2 to the g times the derivative of the exponent. Okay, copy paste times the derivative of the exponent. Copy paste times the derivative of the exponent. Oops, almost forgot. Times the natural log of 2. Oopsies, there we go. E doesn't need it. E doesn't need it because I'm going to put it in a little cloud. What's the natural log of E? It's just 1. So it's there, but we don't write it because what's 1 times anything? Whoops, you can't see the heck I'm doing. Sorry. There we go, better. So we don't need to write times the natural log of E because, well, it's just 1, right? They're inverse functions of each other. What do inverse functions do? Oh, they cancel each other out. So we don't write it. It's just a special form of the exponentials. Now, log and natural log, similar natural log because it has the assumed base of E. Again, we don't need this extra little bit here, but in general, if I have the derivative of log base A of x, then it equals 1 over the argument of the log, so 1 over x, times, in the derivative, the natural log of the base. Okay, so very similar to E because, again, exponents and logs are inverse functions of each other. So whatever an exponent can do, a log can do, like similar but different. So if I have the natural log of x, that's just 1 over x. Okay, the natural log of x is 1 over x because, again, the assumed base e for natural log would give us the natural log of e, but that's just 1, right? That's just 1. So we don't write it. But again, don't forget chain rule, like it says there. Chain rule, chain rule. So if it is the log base a of g of x, so some function we'll look at here in a hot second. This is y, then y prime is 1 over g of x times the natural log of a, and then times g prime of x. So a lot of times we'll get g prime of x over g of x times the natural log of a. There you go. All right. So again, natural log of x, we don't have to have that extra natural log bit in the denominator because the assumed base is e. Natural log of e is 1. So there you go. All right. So let's do some examples. About the derivative. So remember, it's a copy paste job and then just times the derivative. So if we want to say this is 3 to the g of x, well, then our supposed g of x is 9x. The derivative of that is just 9. So f prime of x, copy paste, 3 to the 9x, now times the derivative of the power 9. That's it. We might say 9, oops, times 3 to the 9x. Do not call that 27, right? This is 9 times this exponential, okay? That is not times 9 times 3, that's 9 times the exponential. The 9 is now a coefficient of the exponential. So be super crystal clear on that. That is not 27. All right, let's go here. Y equals E raised to the natural log of X quantity squared. All right, so here, remember that we have exponent laws, that Y is E times 2 times the natural log of X, right? The exponent, the power rule says we can bring the power down in front. Let me zoom this in a little bit, sorry. Bloop, 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 bloop. And autofocus. There we go. Hopefully that's better. Maybe you needed it, maybe not. Sorry. Okay, so now I can rearrange this to say this is E squared times the natural times E times the natural log of X, right? Because here, if exponents are, well, that's well added. So that's an exponent to an exponent. Why is my brain not working? We can multiply them. Come on, brain, work together. That would be if it was 2 times. No. So 2 can come down in front. Natural log of X squared. Why is my brain not working? E, that can come down in front. This, yeah, that's fine. Okay, we'll get out of it. Okay, we'll just go the other way around. So E times the natural log of X. Well, what is that? E in the natural log. No, okay, sorry. Switching gears on y'all. I apologize. Let me go to a different color so we just totally switch. Here, let's just go back to chain rule. So if we think of this as Y equals E to the GX, well, our G of X is the natural log of X quantity squared, which is chain rule for G prime, which says 2 times the natural log of X times the derivative, which is 1 over X. Okay, right. Because the 2 comes down in front, power rule says now that's the power of 1 times the derivative of the inside, which is 1 over X. So our Y prime is copy paste E raised to the natural log of X quantity squared times the derivative of the power, which is 2 times the natural log of X all over X. There you have it. Remember, this is the natural log of X. So you can't see, sorry. This is the natural log of X. The X's do not cancel. This X is the argument of the log. Okay, that X is the argument of the log. Okay, that is the argument of the log. So all in all, we got this whole thing. Perfect. Oops, see my little smiley face? Okay, C. I would like for you to pause the video, try C, and then when you're ready, press play. Press play. Okay, so we have Y equals log base 2 of X squared plus 3X to the fourth minus 7. So you just go by the derivative log rule right here. All right, so it's 1 over the argument times the natural log of the base. So Y prime is 1 over the argument. So X squared plus 3X to the fourth minus 7X times the natural log of the base, which is 2. Now times, like our chain rule says, times the derivative of the argument. So that is 2x plus what? 12x cubed minus 7. There you go. So this was in the numerator, 2x plus 12x cubed minus 7 all over x squared plus 3x to the fourth minus 7, and then times the natural log of 2. That's it. You didn't think that was too shabby. Let's keep going. If I can get my paper. There we go. All right, so now find the equation of the tangent line at x equaling 2 of g of x equaling 16 raised to the x squared plus 2x plus 7. So remember, this says that equation of the tangent line is y minus y1 equaling slope of the tangent line times x minus x1. Our x1, so to speak, is 2. Our y1 is g of 2. So that is 16 raised to the 2 squared plus 2 times 2 plus 7, which I'm going to cheat and grab my handy dandy calculator. So let's see, 16 raised to the, what, that's 4. That should be a 2. This is why I need y'all. 4 plus 4 is 8 plus 7 is 15. Oh boy. Let's just leave it at 16 to the 15th. Let's just do that. Okay. So we have our x1, our y1, that is 2 and 16 to the 15th. So our point is 2 comma 16 to the 15th. Now we need our g prime, and then we're going to pop in 2. Right? We need our g prime, and then we're going to pop in 2. So g prime of x is copy paste 16 raised to the x squared plus 2x plus 7. Now we're times the derivative of the power because chain rule. So times 2x plus 2. That is all of g prime. Now we need the slope of the tangent line, which is g prime of 2, which we already know, copy paste, that this is 16/15 times 2 times 2 plus 2. 2 times 2 is 4 plus 2 is 6. So this is 6 times 16 to the 15th. Okay. All right. So now for our equation, this is just y minus 16 to the 15th equals 6 times 16/15 times x minus a 2. We distribute. I'm going to come up and over. Make sure you can see. This is y minus 16 raised to the 15th equals 6 times, oops, excuse me, 16 to the 15th x minus 2. So that's 2 times 6, which is 12 times 16/15. Now we're going to add, oops, sorry, let me switch this over. Right, 12 because that's 6 times 2, right? The 6 is just a coefficient. Now adding this over, this is considered 1/16/15. So we're going to subtract 1 off of here. So this is y equals 6 times 6/15 x minus, because we're adding this over, 11 times 16/15. And we're going to leave it as that. That's super ugly and messy, but that's fine. We're just practicing. Okie dokie. Next, calculate the derivative of, oh boy. Y'all want to take this one for a test drive? Let's see. So we've got y equals log base 3 of 2x squared plus 7x all quantity squared times e to the 4 x squared minus 3x. So first we need to recognize that this is a product rule, right? We have this thing times this thing. So let's just call this our f and this our g. So f, this is crazy. craziness. Log base 3 of 2x squared plus 7x quantity squared. G is e to the 4x squared minus 3x. Now f prime, so it's 1 over, oh, this whole thing is weird, excuse me. So we have a chain rule. So we have to take care of the 2 first. So it's 2 times, copy paste, log base 3 of 2x squared plus 7x. Now all of this is technically to the first power, right? We just did chain rule of power rule. Now times the derivative of the inside, which is the log derivative. So it is 1 over the natural log of 3, right? Because you always have to take the natural log of the base. The argument of the log, which is 2x squared plus 7x. Now times the derivative of this thing, which is 4x plus 7. Ooh-wee, ugly, ugly. That's okay. So all in all, we've got, let's see. Oh, that is there. This is 2 times, I'm going to move the 4x plus 7 to the front, times the log base 3 of 2x squared plus 7x. And then all over, oh, I need to print this there. The natural log of 3 times 2x squared plus 7. Ooh, wow. That's a doozy. A doozy. Let me zoom out for you. Sorry. There we go. A doozy of a derivative. Well, that's why we've got crazy ones in here. So when you hit the homework, they're not as crazy. And then E. Remember, E derivative is copy paste of itself. E raised to the 4x squared minus 3x. Now times the derivative of the power. So that is 8x minus 3. Okay, now recall power rule. Says that y prime is f prime g plus g prime f. It's going to be real squirrely looking, but that's okay. It didn't say, make it pretty. It just said take the derivative. I'll do it in purple. Yeah, let's do it in purple. Why not? Gosh, I wish I was in the classroom. This is so boring. I like being with y'all. Away we go. All right, f prime. This craziness right here. So y prime is equal to 2 times 4x plus 7 times log base 3 of 2x squared plus 7x all over the natural log of 3 times 2x squared plus 7x. All right, ugly, but whatever, that's fine. Times g, e to the 4x squared minus 3x, now plus g prime, which is right here, e to the 4x squared minus 3x times the derivative of 8x minus 3. Now times plain old f. That is log base 3 of 2x squared plus 7x. And then all of that quantity squared. Ooh-wee, is that ugly or what? Now, because they both have the e term, what we want to do, because eventually we're going to solve this stuff, it won't be as crazy, but when we hit first derivative rule, second derivative rule, that stuff, we're going to be solving. So let's just get in the practice of taking that e out. So I'm going to call this e to the 4x squared minus 3 to the x times 2 times 4x plus 7 times the log base 3 of 2x squared plus 7x all over natural log of 3 times 2x squared plus 7x. All right, good, good, good. Plus now these two terms. 8x minus 3 times log base 3 of 2x squared plus 7x quantity squared. Close the bracket. because the e to the x has a term in here and a term in here. So eventually we will set this to 0 and solve. We'll set this to 0 and solve. When we get to that point, this part won't be as crazy, I promise. Just bear with me. Let's not, jump ahead too much. Don't freak out on me. But that's eventually what we're getting to. So that's why I want you to get in the practice. Okay. So find the derivative of y equaling e raised to the 1/2. Oh, excuse me. I'm giving my tricks away. Square root of x squared plus 10. I really want you to pause the video and try this one. Okay, please pause and try this one. Okay, let me zoom in. Find the derivative. Remember, y prime is going to be copy paste e to the g times the derivative of the power. I highly recommend you rewrite this, remember the square root, as its power of 1/2. It'll help you find your g prime. So down here, if g is x squared plus 10 to the 1/2, well, g prime is its own chain rule, right? The 1/2 comes down, copy paste the inside, bring 1/2 down by 1, so that's negative 1/2. Now times the derivative of the inside, so 2x. So now we're just going to follow this. So let me change colors for visual effect. So y prime is equal to, copy paste. Okay, cool. E. We'll do square root, it really doesn't matter. To the x squared plus 10 times the derivative of this. We got that right here. Oh, but look, that 2 and that 2 cancel because that 2's in the numerator, that 2's in the denominator. So it is x over the square root of x squared plus 10. Fun. Of course, we can rewrite it over the same thing, but we don't have to. X e raised to the square root of x squared plus 10 all over the square root of x squared plus 10. Ooh, that's beautiful. You don't have to do that though, but ooh, is it pretty? Ooh, is it pretty? Okay, oops, sorry. I'm going to stop record and do another video for the last half. Oh, sorry. Now I'm going to stop recording. Gosh, there's so many buttons.